Hey everybody, so today we're going to be talking about data visualization. And so when we get a set of data, oftentimes we really want to understand what that data is telling us. And humans are really good at recognizing patterns visually. So instead of just getting some numbers out from our descriptive statistics, sometimes it's a lot better for us to just plot the data and see what it looks like. Also, this is going to allow us to maybe find some discrepancies and some problems in our data before we go into the analysis. So we're going to go over some of the ways we can plot and visualize our data using a single variable, so univariate, or we're using two variables, so plotting one against another. We'll see what I mean by that. So let's get into R and start off with getting to visualizations. All right, here we are in my R screen, and I'm actually going to put myself up into the top corner because right behind me here is where all the plots are going to show up. If we look up here, we see there's a plots tab, and when I create a graph or a plot, it's going to show up in this tab. So I'm just going to move myself up here so I'm out of the way of all of that. So the first thing that we're going to do is we're going to load a couple of data sets and some libraries. So the first one we'll do is we'll load up the tidyverse library because we're going to actually subset our data right off the bat. So I'm just going to type in library tidyverse and run that. Remember again that I used my Control Enter keys to run that, but you can also use this run button up in the top corner. So I ran that, and you can see that the tidyverse package has been loaded, and it's down there in the bottom corner. Okay, great. So the next thing we want to do is we want to load up our heights data again that we've been using. So I'm going to use the read CSV function, but we can also just load that up by using the import data set up here in the top corner. But I'm going to create an object called heights underscore long. And into that, I'm going to use the read.csv function and tell it. Now I just have to tell it where my data is. And because all of my data files are in a folder called data that's located under my R folder, I can just type in data because it knows to look in its current folder to find a data folder that is located right where the R project is located. So it knows to find it there. If it's somewhere else, you're going to have to actually tell it where to find that data. But I can just type in data and then / heights underscore long dot CSV. Now, in addition, I'm going to add strings as factors equals true. I'm going to add that to the command. Now, when I run that, it imports that data set as we've seen before. Now, the next thing I want to do is I just want to create a couple of subsets of that data, which will be heights F and then heights M. So heights F is just going to be using our filter command. Filter heights underscore long, comma, where sex is double equal to F. And I'm going to copy that whole thing and paste it and do the same thing for heights M. Heights M, where heights is equal to M. That should give me two new data sets over here in this object that are the different numbers of observations of these values and heights. Okay, so on to visualization. How do I actually visualize this data? The first thing I could do is I can just use a command that's included in the base package of R, or we call it base R, called plot. And I can simply say plot heights underscore long. Now, if I do that, what we see down below here it does a rudimentary plot of my data. And what we really see is that we've got all these data points represent various heights, and it looks like it's taken my sex, males and females, and coded them as 1 and 2. I think females are 1 and males are 2. It's just tried to plot the data as best as it can. So that's one way we can plot the data, but it's not really very useful. But maybe we might be able to see if there's a massive outlier or some piece of data that doesn't make sense at all, somebody with a height of 0 or 999 or something ridiculous. Another way we can actually look at this data is by using another command that's built into the base R package called hist. And histogram, or hist, is just short for histogram. So I can ask it for heights underscore long, but now I have to tell it which column of data that I want. And I know in my heights long data, if you can't see it behind me, but click on the little table picture that is in the object, I see I've got a column called height and a column called sex. I'm going to close that. So I want a histogram of heights, long, and then remember we used the $sign to pick which column, and it shows me here I can either pick height or sex, so I want height. Now, if I run that, I'll get a histogram of the heights, and the histogram is simply counts within each sort of range of heights, or bins we call them. So 150 to 155, it looks like I've got 3. 155 to 160, there's about 4 people in that height bin. So that gives me an idea of what the distribution of my data looks like. Now, I could also do a similar sort of thing looking at sort of the number of people in each of my categories, males versus females. But here I can't do a histogram of that. I can't do a hist command. I have to use the plot command. And so if I do plot heights underscore long, $sex, actually it's not a small s, but it's nice. I'm just going to select that and it will automatically capitalize it for me. Run that. It will show me my counts. So it looks like I've got 20 females and about 16 males in this data set. So that's pretty nice, but I think there are a lot nicer ways to plot this data. Now we could go ahead and we could do the same thing. I'm going to just copy and paste this. So I could do, instead of heights long, I can do it separately for females now, where I get my histogram of females, or I can do it on the data set of heights M, and that'll give me a separate data set for my males. So I can see the heights for those different sets separately. Now, like I said, the base package of R has some basic graphing tools, but I think that there's some better ways and easier ways for us to be able to visualize our data. One of those packages is actually called flexplot. Now, flexplot is actually not a package that you can install in the regular way, like by going to packages. If I search for this and try and install flexplot, it won't find it. We don't find. There's flex param curve or flex polyline, but no flex plot. So that's because it's a package that's not hosted in the regular R repositories, but it is found on GitHub, which is a repository for open source software. So the way we need to install this is, first we have to install a package called DevTools. So DevTools is development tools, and it is a package that we need in order to be able to install things from GitHub. So again, we could do this from the install command and search for DevTools. So if I click on that, I hit DevTools, I click on install. It's telling me that one of the packages to be updated are currently loaded. It says restarting R prior to install is highly recommended. I'm not going to bother because this just sends me into a loop. So I'm going to say no to this and let it do an install of this. The reason it told me this is probably because I've already got DevTools installed, but I wanted to show you how to do it. Now, in order to use this package, I need to load it, which means I need to use the library function. So library DevTools. Now, once I've got that loaded up, I can actually install the flexplot package from GitHub. The way we're going to do that is going to use the command install, and I'm going to scroll down here to install GitHub. So not git or dev, install GitHub. And then we need to tell it where to find it. So I'm going to go quote, and it's Dustin Fife. So DUSTINFIFE /flexplot. So I'm not going to run this because it'll give me an error because I've already got flexplot installed, but you should be able to install it without any errors. Now, once you've got that done, you can use the library command, library flexplot, to load up that package, and it should give you a confirmation down here that it's all loaded up. So now that we've got that loaded up, we could do a couple things. We could use $flexplot and run that, and this will give us some help on how we use flexplot down here in our help tab. But basically the idea is that flexplot uses a similar grammar. Basically says, I want you to graph whatever it is on the y-axis and then on the x-axis, and then we can also give it parameters for panels and then different rows of panels. But you don't really have to worry about that right now. We'll get into those much later as we get on with this. So now that we've got flexplot loaded up, we can proceed to doing some univariate visualizations. So univariate visualizations are what we've seen before, histograms, and then just bar charts of categorical variables. Now, in order to use flexplot to create a histogram, we would use it in the following way. We use flexplot, and then we take our variable of interest, height, and we say tilde1. So height as a function of 1, this will give us a histogram, or it'll give us a bar chart if it's a categorical variable. So we go height as a function of 1, comma, data equals heights underscore long. If I run that command, what we see is we get a histogram of our heights data as we've seen before. Now I can also use the exact same command if I wanted to change the number of bins that I've separated these into. I could change this into, I could give it an extra command where say bins equals 20. Now we can see it makes smaller bins here to separate these into. I could change it to bins equals 30, and it changes it to smaller bin sizes. So you can specify whatever you like. If you don't put anything in there, it'll pick what it thinks is appropriate for the number of bins. So we can also do this for individual data for the females or males. Instead, height as a function of 1, data equals heights f will give me the female data, or heights m will give me the male data. So this is really very similar, but we can see we're always using the exact same structure. Similarly, if I want to copy and paste this again, but now instead of height, and I'm going to, in fact, use the heights long one because that's the data that I want. Now, instead of height, I want to look at sex as a function of 1. So that just basically means give me a bar chart of my sex variable. And I run that, we see that we get this chart behind me or below me, which has 20 females and 16 males. So that gives me the counts of my two categories. So the reason we may want to do this is if we look at our data and we might see that there's some problem with our data, there might be some outliers, or there might be some problems with labeling. So I'm just going to show you an example of what this might look like. So I'm just going to load up a data set that's basically called a muscle data set. And it looks like this. I'm going to just run this from my muscle outlier CSV, going to load that up. You don't have to worry about it. This is just to demo this for you. So I'm going to do a flexplot of muscle gain as a function of 1, comma, data equals muscle. Now, if I plot that, what we see is it gives me a nice histogram again. But what we can notice right away is that there's one data point way out here that looks like it's way higher than the rest of those. So it's really easy to quickly see that, hey, look, I might have a problem data point here. Now, is it possible that somebody had a muscle gain of 99? Well, maybe not if this is measured in pounds, because that would be really unlikely. So you may want to check those data points. Now, similarly, I might want to look at intervention. As a function of 1. Now, in this data set, what we've got is basically muscle gain as a function of either protein intake or exercise that's been done. So if I do this, we say, okay, well, I've got I should have 2 categories, but all of a sudden I see that there's 3. I've got protein and exercise, but I've also got workout. So it looks like there's been one of these instances has been mislabeled as workout. I assume it probably should have been exercise, not protein. So we might need to go in, identify what the problem is, and maybe relabel that as exercise instead of workout. So this gives you an idea of how you can use these univariate visualizations to really quickly find out where you've got some potential problems in your data and to be able to really understand your data really quickly. So we can imagine where I would want to now say, I'd like to look at the heights histograms, but I want to see them separately for each sex. Now we can do that in flexplot fairly easily by group. So we use the same command here, flexplot as a function of 1, data equals heights long. But what we do is we add an extra argument in here. And what this bar does in the middle here is it says, give me 2 separate panels, and then we just type whatever variable it is that we want. So we've got heights, we've got flexplot height as a function of 1, paneled on sex, and then our data is heights long. When I run that command, what we see is it gives us a 2-paneled graph here that has females on one side and males on the other. And they're actually nicely put onto the same sort of length of scale. So this allows us to see both of those at the same time. Now, there's lots of other ways we can use different packages that are available in R to do some graphing, but flexplot is one that's really easy. But I'm going to show you really quickly a couple of different ones that allow us to do some visualizations and you might be either more familiar with or you might use in the future. So the first one I'm going to show you is called sjPlot. And sjPlot is actually part of the tidyverse package. Now, it's already loaded because we loaded the tidyverse library, but you could also load it by typing library sjPlot 2. There's a 2 at the end, just remember that. If I run that, it loads that package. It's already loaded for me anyways, or you could also load it using the library tidyverse command. So if I actually do that, it's done the exact same thing. So what I'm going to do then is show you how we use the sjPlot function. So sjPlot uses the function sjPlot GG actually means grammar of graphics. That's what it's for. So sjPlot, we need to tell it the data set first. So heights underscore long. And then what we need to do is give it what's called an aesthetic. Because when we just tell it to ggplot heights long, it gives us a blank canvas. So we need to tell it what the X and the Y variables are. Now, in this case, when we want to create a histogram, we only actually care about giving it an X variable. So I tell it AES, so that means the aesthetic is that X equals height. Now, if I run that, it's not really going to do very much because it doesn't even know what to do with that data yet. So I need to add a geometric form. So this is the way that ggplot is used. You build up from a blank canvas, basically. So the next part we're going to do is just give it a geom underscore histogram. So it was automatically filling it for me and I just hit tab. And then I'm just going to go open, close brackets, and that'll just create a histogram. We can see that it's created me a very basic histogram by doing that command. If you want, it's great to go and get a more full tutorial of how to use ggplot online. There's a really good tutorial using the R for Data Science ebook, which is available for free online. And that ebook is available at the link I'm going to copy and paste here for you. There we go. https r4ds.hadley.nz, or NZ for our American friends. All right. So I can also use the same command. I can add in within this a secondary aesthetic. So if I put into this ggplot command that I just ran, and inside the brackets for a geom histogram, I added an AES, an aesthetic for color equals sex. Now what we can see that it's coded our ggplot by sex, males and females, this histogram. So that's another way we can actually create a histogram that's got both males and female heights on it at the same time. So another package we can use that easily lets us create different types of plots and that we'll use in the future, you may want to load in just because you're going to use it, is called sjPlot. So you might want to search for that package using the install, or I'm going to just type in install.packages and it's called quote sjP plot. Now it's going through and it's installing that package. It says that it's been successfully installed. Then I can make sure I load up that package, sjPlot, select that, control enter. Now that it's loaded up, I can use the sjPlot command. So that is there, sjPlot height as a function of sex, comma, data equals heights underscore long. Now, when I do that, you see it gives me this pretty busy graph where it's done a histogram of heights separated by males and females, and it's also overlaid the number and percentage of each of those bars. So it's gotten pretty busy, but you can actually make this a lot cleaner just by using a couple of different commands. And we'll get into those later. All right, so that has really been a quick tutorial on how we do univariate visualizations in R, and we used the base package, we used flexplot, we used a little bit of ggplot, and we used a little bit of sjPlot. So in the next video, we're going to get into bivariate visualizations, which is basically plotting one variable against another. So I hope to see you in that one.